Welcome to the business system method, second session. Topic is correlation. Now here we are covering measurement of correlation, Carl Pearson's coefficient of correlation. You see, in a scatter diagram, you are not able to obtain the exact value, exact amount with which the two variables are correlated. Here, to overcome this, Carl Pearson has given a formula for the computation of relation between two variables. It is a exact measure of correlation is measured by Pearson's coefficient of correlation, and it is given by the following formula. Next, RxY means correlation between x and y. Notation is R is covariance xy divided by sigma x into sigma y. What is sigma x? It is covariance divided by square root of variance of x into variance of y, which is covariance x divided by standard deviation of x into standard deviation of y. But if these values are not available, for any sets of values, pairs of values, you have to use n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x whole square into n sigma y square minus sigma y whole square. Denominator is under the square root. It is nothing but the standard deviation that we have calculated earlier. But for a bivariate data, this also can be changed. If x and y's are normal, if x and y's are greater in magnitude, then what we are going to do is we change x to dx. What is dx? dx is x minus a by 10, x minus a by b. What is dy? It is x minus b by c. Then you have to find this, use this formula. All are same, but under different data given, you have to use n sigma dx dy minus sigma dx into sigma dy divided by square root of n sigma dx square minus sigma dx whole square. Similarly, into n sigma dy square minus sigma dy whole square. For a bivariate data, this problem becomes sigma f dx n into sigma f dx minus sigma f dx into dy divided by square root of n sigma dx square minus sigma dx f dx whole square into n sigma f dx y square minus sigma f dy whole square. So whenever we come across such problem, you have to notice. Now here there is a problem given for which you are asked to calculate coefficient of correlation between x and y. Now the values given here are average over the past average. We take one of the variables, subject number is given 1 to 10, then 9 values are there. Now x value 9, we given an experiment conducted on 9 different cigarette smoking subjects resulted to the following data. So a cigarette, this one, x second column you take it as x, then number of years lived, and those who are smokers, 25 year 63 year, like that, 35 year 68. Now you have to take this as x value, the other one as y value, second and third column. You don't have to worry about the which one. Now you calculate the following quantities. X values, once again you write afresh. The value is 25, 35, 10, 40 values are there respective. Next, x square, 25 square, 35 square, you have to find the square values of these numbers to get sigma x square as Find the sum of columns as soon as you write, which is 425. Sigma x square is there, which is 224,525. Similarly, y is there. Y, it is there given in the problem. Y square you have to calculate. What is y square? Which is 39694624 y square. 5184, the respective y square value. 60 square is 36,600. 55 square is 3136. So sigma y square is 33,188. Now last column is x into y. What is x into y? 25 into 63, which is 1575. What is x? 35 into 68, which is 2380. What is xy? The last column. So similarly, you have to multiply 10 into respective values. 10 into 72 is 720. First column into third column is the last column. 25 into 63. The caption heading is explanatory. Carefully you have to notice. So that sigma y is xy is 24,640. When all these values are available, we have to go to the formula. What is the formula? Values for the formula is n sigma xi y is there. To make it easier, I am taking xy. Sigma xy minus sigma x into sigma y divided by n sigma I square minus sigma x whole square, n sigma y square minus sigma y whole square. You substitute the values and simplify to substitute values which are there. Simplify carefully. Numbers are larger in magnitude. Take a separate square root and the value is minus 0.61. So there is negative correlation between the two variables. You have to write an inference. If it is asked, the problem is having 16 marks. Now, problem 2 is calculate the coefficient of correlation between the two variables, which is coefficient of correlation between the two variables. Here given data is series x, series y. Now number of pairs 15 values, number of y 15 values. Now which is number of, which one is variance is given 10 and 12. So if you take standard root, this becomes 15. This becomes which one? This becomes the standard deviation. Therefore, sigma dx dy divided by n into sigma x by sigma into sigma y. Therefore, the value is 122 divided by 15 into root 10 into root 12. You have to simplify these values to get 0.74 as the coefficient of correlation. Now, there is a moderate degree of positive correlation. Moderate degree of positive correlation because 0.74 is there. If the value is nearing 1, there is perfect positive correlation. You can write, or negative also is there. The value always is between -1 and +1. Now, the next problem is to find Karl Pearson's coefficient of correlation, which is here. Given problem is here, which is directly, here also we are not doing directly. Now next is here two sets of values are there when the pairs of values are given. Now it is 2, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 values. First you write the value x. Here we are using the step deviation method, or changing x to some smaller dx, which is directly also you can do x square as I have done earlier. Now x dx is x minus 20, which is 8 minus 20. There are picture 20 is need not have to be a value, but he has taken it as one of the a value. Now x minus 8 minus 20 is minus 12, 10 minus 10, 20 is minus 10, 15 minus 20 is minus 5, 17 minus 20 is minus 3, 20 minus 20 is 0, 22 minus 20 is 2, 24 minus this 20 is 4, and 25 minus which 5 is 25. So this value becomes addition of this value sigma dx is minus 19. Now what is dx square? Minus 12 square. Square of the second column. Square of number is always positive. 144. Minus 10 square is 100. Minus 5 square is 25. Minus 3 square is 9. 0 square is 0. 2 square is 4. 4 square is 16. These values you have to find. Now y, it is given in the problem. Now y minus 30 is the value. Y minus 30 is the value of the coefficient of correlation you have to find. So which is y minus, what is this, 30. What is this? 25 minus 30. Rough value between minimum and the maximum. When where b comes, don't ask. One of the value that you can take. Even 25, 31 also can be taken to change x to y. Now x to y to dy. Then 25 minus 30 is minus 5. 30 minus 30 is 0. 32 minus 30 is 2. 35 minus 30 is 5. 37 minus 30 is 7. 40 minus 30 is 10. 42 minus 30 is 12. 45 minus 30 is 15. So which is sigma y is dy is 46. What is dy square? Dy square is dy square you have to minus 5 square, which is 25. 0 square is 0. 2 square is 4. 5 square is 25. Next is 10 square is 7 square is 49. 10 square is 100. Then 12 square is 144. 15 square is 225. Total 572. Now dx dy is the product of two columns. Which one? Dx is the second column. Dy is 15 column. Fifth column. Minus 12 into minus 5, which is 60. Minus 10 into 0, which is 0. Minus 5 into 2, which is minus 10. Minus 3 into 5 is minus 15. 0 into 7 is 0. 2 into 10 is 20. 4 into 12 is 48. 5 into 45 is 75. Now addition of this one is sigma dx dy, which is 178. So now you have to use this formula. R equal to, mean is a fraction. Mean we have calculated, and you need not have to calculate. A rough picture of x bar is 141 by 8. Then y bar is 1 sigma y by n, which is 286 by 8, 35.75. Since the mean is a fraction, number we can apply any assumed mean means assuming some other value closer to the next integer. So r is n sigma dx dy minus sigma dx into sigma dy divided by square root of n sigma dx square minus sigma dx whole square into n sigma dy square minus sigma dy whole square. So substitute the values. 8 into 178 minus of minus 19 into 46. Next term divided by square root of 8 into 323 and minus of minus 19 square. I am substituting the values to get simplify and to get the 0.9827 as the coefficient of correlation. So very high degree of positive correlation is the inference that we have to write at the end. That means as x increases, y also increases in the same direction. It is visual, it is clear by inspection too. Now next is your you have to see any type of problems you have to see either direct method. By direct method also you may solve. Which one? X square, y square and xy. Or just to know that to make the larger magnitude values as smaller, we are changing x to dx, y to dy. That's all. This is how we are going to calculate. And whenever you write, work it out independently once if you know. And use this one in formula based on the given data. That gives the exact value. Here I have given references by UK Srivastava. Next, thank you.